In this video, I'm going to demonstrate how to use the algebraic properties of logarithms to put together an algebraic formula. Now, let me give a quick explanation of what I mean by that. In the previous video, we talked about taking apart an algebraic formula. We used the algebraic properties of logarithms, and we looked at a formula like this and matched it against a formula. For example, this one was where we started, and we used the equation here, and we rewrote the matching part of our formula in progress according to this. All right, so once again, we matched part of the formula that we're working on to the formula over here and rewrote that part using the right-hand side. So to sort of simplify this, for taking apart, you work outside in, and as an example, you match something like this against the left-hand side, and then rewrite the original formula using the right-hand side. So here, I've matched ln of x cubed times y squared against ln of u plus v. I've recognized that I can take that apart as ln of x cubed plus ln of y squared, and so on. For putting together, the goal, instead of trying to make it so that as little as possible is inside a logarithm, the goal now is to put everything inside one application of ln. To do that, we generally work inside out. So instead of working from left to right using the formulas as I've written them over here, we will instead be working right to left. That means altogether we're going to be looking for small parts of the expression that we're working with, try to match them against the right-hand sides of these formulas, and then rewrite that part of the formula into a bigger part using the left-hand side. Now let me demonstrate. Here's our first example. So that is, let me get back to my tablet here. I'm going to copy this down for reference. Our example is z equals 1/2 ln of x minus 3 times ln of y. Now again, I'm going to draw the algebraic structure here. Function application happens early in the order of operations. Remember, this is something we don't have a letter for it in PEMDAS, but it happens very early in the order of operations. The 1/2 happens, and then we have the multiplication here, and the multiplication here, and then finally the subtraction happens. With putting together, we'll start with an inside application. In other words, we're going to start with something small, something like this or like this, and rewrite it using these algebraic properties of logarithms. Let me rewrite this with a little less visual noise. And let's focus first on, say, this. That's a small substructure of this overall algebraic formula. Now, looking at the right-hand sides of this table of formulas, which one could we possibly use? Right, we need this one because that one has an m. We can make m times ln of something that we'll call v. And when we put that together, we'll get ln of v to the m. What that means is that I'm going to rewrite the 3 ln of y as ln of y to the third and leave the rest of the formula in place. So everything else is the same. All of the structure is left unchanged, but what we've done is to change this small piece, the 3 ln y, using one of these algebraic properties. Now we can do actually the same thing over here. Right? This I can match m times ln of v, same formula, and rewrite this part. And the rewrite is that I need ln of v, which in this case is this x. And let me see, I'm running out of space for my arrows. Then I need an m right there, and the m is this 1/2. Okay, so now let me put all the arrows back in. The rest of the formula is left the same. So after one step, we've got z equals ln of x to the 1/2 minus ln of y cubed. Now we need to do one more step. So looking at the formula here, looking at that expression, which of these could we possibly use on it? Let me grab my thing and move it down. Which of these formulas could we apply to this? Right, must be that one. That's the one that has ln of something minus ln of something else. So I'm going to look at this ln of u minus ln of v, which can be written as ln of u over v. I'm going to use x to the 1/2 for u, y to the third for v. So when I rewrite this, I'll get ln of division the v is y cubed, that's over here, and the u is x to the 1/2. So at this point, we've now pushed everything together so that z is ln of one thing, and that's it. So x to the 1/2 over y to the third, and that's our end goal. This is the kind of thing that you would be asked to do on the electronic homework. Okay, so now that we've done that one, let me copy the list of formulas. Let's try this again. Copy the list of formulas, move it down the page, and let's look at our next example. Okay, so there you go. That is z equals ln of x plus 1 plus ln of x plus 3. Well, looking at this algebraic formula, which of these formulas can we use? This one. Nope, that was the wrong one. It's plus. Sorry. We want to use this one because we have ln of u plus ln of v. The u matches with x plus 1, the v matches with x plus 3, and we want to rewrite that as ln of u times v. Okay, so z equals ln of, I need to put in u, so that's x plus 1 times v, x plus 3. But oh, what mistake am I about to make? Parentheses. I need to be sure that what I write means the result of multiplying u times v. And without those parentheses, we would only have part of u multiplied by part of v, which would be wrong. So this example is actually pretty easy. There's only one step that we can do. Now, if you really wanted to, you could FOIL out the stuff there, the x plus 1 times the x plus 3, but it's not absolutely necessary, and I'm not going to do it right now. Here's our next example. So take a moment and try that one on your own. Okay, let's work on this one. Z equals 2/3 of a group ln x minus ln of y. Now this is part of why I mentioned that you should work from the inside out, because the first thing that we're going to be able to do something with is the stuff inside the parentheses here. We'll handle the 2/3 later. Okay, so of these formulas, which one can we apply to that part of the expression for z? Right, that one. So I need to write z equals 2/3 times ln of x divided by y. Now looking at this, Out of these formulas, which one can we apply? This one. So, need to write z equals ln of x over y to the 2/3. And what mistake am I about to make? Parentheses. Yeah, let me make this even bigger so that you can see. That's what's going on there. Now, as to why is that necessary? Well, let me be a little more careful about how I write this. Remember, what we're going to do is match this formula against that part of the expression for z. So there's m, ln, and then the v is x over y. This is how I have to rewrite it. Well, if I'm going to use power 2/3 and apply it to division, if I don't have the parentheses, then the interpretation of this is to apply power 2/3 to x. Let me draw it like this: is to apply the power 2/3 to the x, then divide the result by y, which is not what we want. We want power 2/3 applied to all of v. That is, we want to do this, which means we need those parentheses. Let me put them in the correct color. There we go. So that is how to put together that example. Okay. Now, that's it for my putting together examples. I'm going to stop here and start another video, but part of why we're doing these take apart and put together exercises is that we're about to start solving equations involving logarithms and exponential functions. And in order to do that, we'll use a combination of taking apart techniques and putting together techniques.